let's discuss possibilities. If I say let y be the square root of natural log x, let's see what happens. I need dy. dy will be 1 over 2 the square root of natural log x, right? Because so when I differentiate the square root, I have 1 over 2 the square root of the function times the inner function prime times dx, of course. Do I have all this? Of course I do. Do I have 1 over x times the square root? Yes, it's right here. Do I have dx at the top? Yes, I do. What I don't have is this little 2. Who cares? I made it up. I multiply the denominator by 2 and the numerator by 2. So now all this is dy. And I don't need anything else. So this is the integral from e to the 16th. I just say that every time. Please do not copy the limits of integration. And I copied them. So this is the integral from dy. As everything is accounted for. Dx, x in the denominator in front of the square root, and the 2. Everything is accounted for, and this is dy. But now, when x is e, natural log e is 1, the square root of 1 is 1. Now, e to the 16th, natural log of e to the 16th, I bring down 16, I have the square root of 16 times natural log e, which is 1. So this will be 4. It cannot be nicer. So this is 2y from 1 to 4. I plug in 4 minus when I plug in 1. And 2 times 3 is 6. Very nice problem. I love that. Do not copy the limits of integration. I'm talking to myself now. Because I did it.
No, I remember that now. We went over that like 2 or 3 classes ago.
I know. But look, I wrote it quickly and without thinking. Good, very good question. Next question. Anything? Next question, anyone?
All of my questions have been answered.
Okay.
But I'll stick around for the other questions.
Thank you. Anything else? Do you need help with anything else? Anyone?
I've already gone over this, and I think it might have been last class or.
That's okay.
But it's gonna be.
If we need to do it again, let's do it again. Any problem?
A limit of a rhyming song. We do one of those.
Yes. Oh.
I don't have a specific one, but I can pull one up.
Yes. So give me a function, because you're going to have something like this, and it's also on the assignment for Sunday. Give me a function that is linear, quadratic, or cubic. So we can determine an interval, of course.
Oh, I got a good one right here.
I'm ready.
F of x equals x squared plus the square root of 1 plus 2x.
It has to be linear, quadratic, or cubic. The square root, if it has the square root of x in it, I cannot do it. I can approximate it, but I cannot determine the exact area with the limit of the Riemann sum. Because remember, we only have the sum of 1, the sum of I, the sum of I squared, and the sum of I cubed. This is all we have. If you ask me to find the sum of the square root of x, I don't know. I can only approximate it, but I cannot determine the exact area.
So then we'd only be finding an expression.
So to find the exact area, we have to use a linear, quadratic, or cubic with the limit of the Riemann sum. We can do it with the definite integral for many functions, not all, because we don't have all the tools in this class. But we can definitely go through the limit of the Riemann sum with the exact area. You will have a problem like this. It's no secret. So we want to work on that problem, on a problem like that? Or you're okay with it?
Yeah, can we do that one?
Yes. So let's choose a linear, quadratic, or cubic.
Let's do a cubic.
Okay, I'm ready. Any cubic function and any interval.
Let's do 5x cubed. Can it be like a fraction?
But not x in the denominator. Yes, it can be a fraction. Yes.
I was going to say plus 63x plus 5
Okay.
over 12.
But everything over 12?
Yep.
But if that's the case, I'm going to do this. Good. And now the interval.
Let's say
If you don't start at 0, it will take us an hour.
all right, let's do 0 to 10.
Perfect. So here's the reason why I'm saying if we don't start at 0, it will be more complicated. Because remember, if we start, let's say, from 2 to 10, when we determine xi, because you remember we have 3 preps, when you determine xi, it will be 2 plus I delta x. And then I have to cube that. That's what I'm saying, it will take a while. But if we start at 0, it's the same process. You see the process again, but the calculations will be slightly easier. They will be easier than starting at any other point, any other value but 0. Is that okay with everyone? Are you okay with that? Or you want to start, it's up to you. I just needed more paper. It's up to you. You choose. You want to start at 0 or you don't want to start at 0?
Let's just start at 0.
Okay.
Yeah.
Okay, so if we start at 0, let me remove this so we don't confuse anybody when I scan this. Good. And remember, we have to determine, and we will check with the definite integral. So at this point, I have to get 3 preps done before I even think of writing the limit of the Riemann sum. So prep number 1 is delta x, in which I have 10 minus 0 over n. In prep number 2, I have xi, which is 0 plus I delta x. 0 because that's where we start. I'm writing it like this so you know that if you start anywhere else, you just have to write it in front. So I delta x is 10I over n. And prep number 3 is f of xi, which is 5 over 12 times 10I over n cubed plus 63 over 12 times 10I over n and plus 5 over 12. I will simplify as much as I can. So this is 1,000 times 5, 5,000. I to the third over 12n cubed, because I have to raise everything here to the third power. Here, this is easier. 630 I over 12n and plus 5 over 12. After I have all these preps done, now I can write the exact area as the limit as n approaches infinity from the sum from the first subinterval till the last subinterval from delta x, which is 10 over n, base times height. The height is f of xi. And I write exactly what I see here. 5,000 I cubed over 12n cubed plus 630I over 12n plus 5 over 12. At this point, this does not depend on I. It's always a constant. You remember we put it in front. Even here on that problem from the quiz, we put it in front. This is the delta x. That's why I take it in front. It doesn't depend on the location of the point or the interval that we are looking at. So this is limit as n approaches infinity from 10 over n. At this point, I will write the sum of this plus the sum of this plus the sum of this. But since it's a lot of writing, I'm going to try and simplify a little bit. So I will take this in front. It's a constant. So I have 5,000 divided by 12n cubed and the sum of I cubed from I equals 1 through n plus 630 over 12n and the sum of I from I equals 1 through n plus 5 over 12, the sum of 1 from I equals 1 through n. Okay, now I will replace this by what it equals to. N squared plus 2n plus 1 divided by 4. N plus 1 over 2, everything squared. I will replace this by n plus 1 over 2. And I will replace this by n. So
I'm confused about what just happened. That last step.
Say it again.
I'm kind of confused. Maybe I'm just not seeing it. But where did those function or those expressions come in?
Oh, this is what we know. We have 4 formulas. The sum of 1 equals n. The sum of I is n plus 1 over 2. The sum of I squared, n plus 1, 2n plus 1 over 6. And the sum of I cubed, n plus 1 over 2, everything squared. These have to be known forever. And we proved one of them using mathematical induction when we talked about it. First of all, was this the question, Donnie?
Yeah, that was.
Okay, yeah, this is carved in stone.
But it did help. Yeah, this helped with that topic. But I also think we should go over one, kind of like the one I had asked about, with it as a square root in there if we have to approximate it.
Yeah, it's we just plug in the function. Exactly how you did it on the quiz. You're given the numbers here, but in the quiz, you just have to plug it in the function. Yeah, of course. We'll do an approximation. But this is not done. This is far from being done. Do you want me to stop or finish it up?
Probably finish this.
Okay. So then we continue. So this is the limit. Sn approaches infinity from 10 divided by n. And now 5,000 over 12n cubed times n squared plus 2n plus 1 over 4 plus 630 over 12n 630 over 12n times n plus 1 divided by 2 and plus 5n over 12. Okay. So let's see. Can I simplify anything? Yes, I can. I would like to, I have to get rid of these two from the top, 2 from the bottom. I want to divide 5,000 by, so that's 2,500 by 4, and then 12, yeah. So I'll simplify. I like that. 1250. I can simplify this, and I get 315. And I like it because the least common denominator, so this is limit. As n approaches infinity, the least common denominator, so I do have 10 divided by n in front, multiplied by. The least common denominator is 12n. Okay. So, 1250 n squared plus 2,500 n plus 1250. Okay. Then also in the numerator, I don't have enough room. I don't need to simplify. I will not simplify. 315 n squared plus 315 n plus 5n. All these are in the numerator. Okay, so now almost there at this point. So limit n approaches infinity, 10 over n will stay in front for now. Okay, so what do I have? I have, okay, 1250 with 315. So it's 1,565 n squared. Now these two, 2,815n and no, plus 5, 20. And plus 1,250. Okay. So finally, the answer would be, after we apply L'Hopital's rule, etc., will be the leading coefficient of the top, 15650, over the leading coefficient of the denominator, which is 12. So, can I simplify by 4? No. Okay, so I can only simplify by 2. So it's 7,825 over 6. Can I simplify this by 3? Yes, I can, actually. 7,825 divided by 3. No, 10? 22. No, I can't. Okay, so now I will check my work. Where's the function? Okay, I want to make sure that this is true. The integral from 0 to 10 from 5 over 12 x cubed plus 63 over 12 x plus 5 over 12 dx. And it better be that, because I don't want to go back and find my mistake. So 5 over 12 x to the 4 over 4 plus 63 over 12 x squared over 2 plus 5 over 12x. Luckily, I only have to plug in 10, and that's good news. So 5 over 48 x to the 4th, just 10 to the 4th, and plus 63 over 24 multiplied by 100. and plus 50 over 12. Gee whiz, how did you come up with these numbers, Danny? So the least common denominator is 48, at least that. Okay, so I have 5 and 4 zeros. 4 zeros, okay. This one needs a 2. So 63 times 2 is 126 and 2 zeros. I need a 2, right? And here I need a 4 plus 200. So 126 and 2 zeros, and this is 5 and 4 zeros. Okay, let's see what we get. 50,000 plus 12,600 plus 200, and I will divide this by 48 just to see if it's okay. So I got 62800 over 48, and I'm gonna check that one. 7825 divided by 6. I do have an error somewhere. So this one divided by 48 is 1308. The other one is 1304. So I have an error somewhere. So let me do this. Did I copy the function correctly? Okay. X to the 4 over 4, x squared over 2, and x. So this was indeed 48. This was 24. And this was, okay, so I plugged in 10. 48, so 10 to the 4th, 63 over 24, 100, and 50 over 12. Okay. Is 48 indeed the least common denominator? 4, 2, yes, it is. 4 zeros, yes. 120, 126, and 2 zeros, and 200. And I think I got 50,000, 12,600, and 262,800 over 48. Okay, now I have to go back here. So 10 minus 0 over n, that's correct. 10i. 3 zeros, yes. 12, yes. 10i over n. 10i over n, yes. And 5 over 12, yes. I took it in front, yes. Then I had 5,000 over 12n cubed, that's correct. Okay, then 630 over 12n, that's correct. This is okay. And squared to n, yes, yes, yes. And this is 5n. Okay, so far I don't see any problem. Okay. I replaced 5,000 over 12n cubed. That was over 4. That's correct. I don't think I made an error dividing that, but I'm checking. Now I'm checking everything. Okay. Okay, over 4 plus. Now 630 over 12n, n plus 1 over 2. So 3, 1, 5. Correct. Ah, yes, I found it. Of course. So this needs to be multiplied by n. That's what problem. That was the problem. Okay, so I have one more time. 1250n squared plus 2500 plus, yes, that's correct. Here, 315n squared, yes, that's correct, and 315n. And this is n squared, because the least common denominator is 12n, so then I forgot to multiply the top by n squared, by n. Okay, so then 1250 n squared plus 315 plus 5, 1570. Let me correct it like this. Okay. Then this doesn't matter, but I have to correct it. So this is 2815, and this is correct. So now 10 times this divided by 12. It has to give us the same answer. So 15700. And these don't matter because at infinity is going to be the same thing. Okay, so I'm checking 15700 divided by 12, and it is exactly what we got here, which has to be the same. They have to be exactly the same. So 62800, again divided by 48, and we have to get the exact same thing, and we do. Yes, I rushed and I did not multiply. The denominator is only 12, but the least common denominator is 12n, so I have to multiply the top by n. So this is where the error was. And I have to erase this one. Okay, so now we can approximate. Let's choose any function, any integral, or I can choose one for which we cannot determine the antiderivative.